Okay, so in this video, we're just going to cover a quick quotient rule question. Just from the front here, you can see the formula that we're going to use to differentiate anything using the quotient rule. And remember, when do we use quotient rule? Is when we're trying to differentiate a function that is expressed as a fraction. That is one function over another function, as we can see here. So looking at the question that we're going to go through, u is the term on top, which is 3x. So if u is 3x, we're going to need u dash, which is going to be the derivative of 3x, which is just a 3. What is v? V is the term that's on the denominator. So in this case, v is going to be the square root of x plus 2, or in other words, x plus 2 to the power of a half. What will v dash be? Well, the derivative of that, which is power down the front, 1 away from the power, and times it by the derivative of what's inside the bracket, which ends up just being a 1. So since multiplying by 1 isn't going to change anything, I'm just going to leave it like that. So we have u, we have u dash, we have v dash. So we've got all the things that we need. The last thing to point out is the derivative of y, right? We saw the formula on the front is u dash v minus uv dash all over v squared. So this is the formula we need to use to differentiate this function. So let's go ahead and do it. I'll do it over here, just where we've got the room. So y dash is going to be, or I should say dy dx, depending on what notation we're going to use. Y dash is going to be equal to u dash v minus u v dash, which ends up being a half x plus 2 to the minus a half, and the whole thing will be divided by v squared. So we square that, and you're just going to end up with an x plus 2. Or if you wanted, you could keep it as the square root of that squared. It doesn't really make a difference. All right, so we've plugged everything into the formula. Technically, this is the differentiated expression. There's a fair bit of simplifying that can be done, and I'll definitely recommend it because this is looking pretty messy as is. So let's go ahead and see how we can simplify it. All right, so having these things, these power over halves, I'm just going to convert them back into square roots because that's definitely going to look nicer. So we have 3 lots of the square root of x plus 2 minus, here we have 3x over 2. Well, this x plus 2 to the minus a half, the negative means that this thing actually exists down the bottom, and the half means it's square rooted. So if I was to write this maybe a little bit neater than what I have, we end up with the 3x ends up on the top, the 2 is on the bottom, and this whole x plus 2 to the minus a half also ends up down the bottom. Okay, so that's looking a little bit nicer, and the whole thing is all over. Well, look, I am just going to write it as x plus 2. That looks way nicer. Okay, so we've been simplifying. I probably will do a little bit more simplifying. Again, I really want to emphasize this thing is now currently differentiated, but we can see we've got all these square root of x plus 2s and x plus 2s all over the place. There's going to be some simplifying, surely. At the very least, we could always just factorize out a 3. Now, looking at the numerator, I see I've got 2 fractions here. I've just turned the first one into a fraction by putting it over 1. And I'm going to simplify these 2 fractions. That is, make the denominator the same. I'm going to use like the small and cross method. Multiply the 2 denominators. We end up with 2 outside of the square root of x plus 2. I'm going to give myself a bit more room here, to be honest. Okay, so here is our big fraction. Okay, now I'm going to simplify the top by combining these into one fraction. Okay, so I've multiplied the two denominators together, and now I'm going to cross multiply. That is this times this. We end up with 6 outside of x plus 2, because the square root of x plus 2 times the square root of x plus 2 just gives us an x plus 2, and multiplying this times this will just give us a 3x. On the bottom we still just have this x plus 2. Okay, simplifying the top. So again, big fraction. What have we got here on this top fraction? It is 6x plus 12, take away 3 lots of x. I'm expanding this bracket. Here, let me do this in red. Expanding this bracket gives you 6x plus 12, take away the 3x. So we end up with 6x, take away 3x. We end up with 3x plus 12. And it's all over 2 lots of the square root of x plus 2. And the whole thing is over x plus 2. Now, what have we got? So again, it's a bit messy, but as far as simplifying, I'm going to go just a little bit further because I actually think this will get a little bit nicer than what it's currently looking. Whenever we have a fraction over a fraction, I always hate writing fractions over fractions just because it gets way too confusing for people when it's written like this. Much better is writing a fraction over a fraction, replacing that big fraction with a divided by. Because in this format, it's much easier to do. We know what to do, right? You change the divide to a times, you flip the second fraction, and it's much easier to simplify. I'm going to do the exact same thing with this. We have this first fraction, which is 3x plus 12 all over 2 lots of the square root of x plus 2. And we're dividing that by this second fraction, which is technically a x plus 2 all over 1. So just like you would in year 7, I might actually just take this 3 out, just in case there's any chance that there's going to be some factorizing that can happen. Change the divide to a times and flip the second fraction. You end up with a 1 over x plus 2. And from here, times in the top, we see, no, it's not going to really work out too well. As far as simplifying, 3 times 1, you end up with a 3 outside of x plus 4. That is our numerator. And on the bottom, we've got a 2. And here we go, we've got this x plus 2 to the half times x plus 2 to the 1. Remember when multiplying, index law number 1, keep the base the same and add the powers. In this case, 1 plus a half. You end up with 3 over 2, or 1.5. You can leave it like this. This seems pretty neat to me. If you really like playing with your food and you want to make it as neat and simplified as possible, you could probably rewrite this 3 over 2 as the square root of x plus 2 cubed. And that there is about as simplified and neat as you're ever going to get it. All right, thanks. Hopefully this was helpful, and I'll talk to you later.